So we're on quiz 20. So you can get out quiz 20, and then I'm going to go right from quiz 20 into starting test 8. And then we'll be finished with this section, and then we'll go on to test 9. So quiz 20 says, what two aspects of chemical reactions are covered under the subject of chemical kinetics? So quiz 20, we're actually starting chapter 13. So there's two different things at the beginning that it says that chemical reactions are covered. They have two different things, two different subjects that have to do with kinetics, which is energy, right? Energy and motion in chemistry. Two things. Number one is the rate of reaction, and number two is the pathway it takes. So the first answer for the first question is the rate of reaction, and the second question is the pathway of the reaction. Number two, what aspect of chemical reaction may be defined as a change in concentration of the reactants or products over time? So when a chemical reaction is measured, the change in the reactants over time, like miles per hour or so, what do you call that? You call it the rate or the reaction rate. Number four, what theory says that the greater the frequency and the greater the energy of collision between reactants, particles, and the greater the rate of reaction? So basically what you're talking about, what theory? There's only one theory that's mentioned there, and it's called the collision theory. Basically, collision theory says that if particles collide more often, the greater energy there is, they're going to collide more often. The greater concentration there is, they're going to collide more often. So they call this the collision theory of atoms. When you have more energy, they're going to bump into each other more. Collision theory. Collision theory is your answer. Number five, in general, does the orientation of colliding molecules affect whether a reaction occurs? The orientation does. Say that two particles are close together, they're more likely to crash into each other, especially if one's moving towards the other one, right? But if they're far apart, the orientation, then they probably won't crash into each other. So the orientation of colliding molecules is affected by its position or orientation, yes. Number six, what name is given to the minimum amount of energy required for a chemical reaction? Do you remember that picture? As you kept going up to the top, and right at the top is where the minimum amount of energy is for that chemical reaction to occur and to get ready to change into something different. We call that peak activation peak. So basically your answer is activation energy. So it says the name given to the minimum amount of energy would be the activation energy. Number seven, what is the unstable high energy arrangement of atoms that is thought to form during a chemical reaction? So this very unstable place is that activation energy at the top. You call that the transition state, or you can call it the activated complex, but it's the transition state is when that molecule, those molecules are going to transition into some new type of molecules. I would call it the transition state. Number eight, as a rule, how much of an increase in temperature is required to double the rate of a chemical reaction? Okay, let's see here. So if you, for each, how many degrees will you double the rate when you're talking about temperature? So if you go up, how many degrees will it be doubled? 10 degrees. Each 10 degrees be 10 degrees. Go up 10 degrees, it's going to be doubled. Then you go up another 10 degrees and you double that doubled. And then you go up another 10 degrees, you double that. So if you have an equation that's 2, so you go up 10 degrees and it will be 4. You go up another 10 degrees and it will be doubled. would be 4 times 2 would be 8. And then you go up another 10 degrees, it'll be 8 times 2 is 16. So see how it doubles. So, but anyway, it doubles on every 10 degrees. Number 9, which of the following statements describes what happens to a reaction between a liquid and a solid in a heterogeneous mixture of the surface area of the solid is increased? So basically what they're saying, if you have a surface area that's increased, say you have a log, well, a log is going to take a long time to burn. But say you take that log and you grind it up into sawdust and then you burn it, bang, it just goes right away because it has a lot of surface area. So basically it says, will the reaction rate increase? Will the reaction rate decrease? Will the reaction rate be unchanged? The effect depends on the volume of the solid. Which one would you say? The reaction rate will increase. So whenever you have more surface area, the reaction rate increases. Number 10, what is the diagram that shows the energy changes during the course of a reaction called? You had that diagram in your book. So is it called the reaction progress diagram? Is it called the kinetic energy diagram? Is it called the enthalpy diagram? Or is it called the potential energy diagram? If you look it up in your book, it's called the potential energy diagram. It tells the potential energy as the diagram is going up, the potential energy to get to that point. Some atoms don't get to the point where they're going to be transitioned or the activation peak there and they fall back, and some do, but that is their potential energy as they're going up, to see, and then they are transformed. Okay, so that's quiz 20. So I'm going to start test 8, going over test 8 here, and because it's going to take a little while. These tests are kind of long, not as long as some, but anyway, test 8. Take a moment. You can turn the video off and get out your test. So, and check it over. So, number 1, what does the field of chemical kinetics involve? So we're talking about kinetic it has 2 different things that it's involved. One is the reaction rates. Remember that? This was on one of your quiz. And the other is the pathways. So is it A, the reaction rates, B, the pathways, both A and B? Yeah, both A and B. So it'd be C. So it's reaction rates and pathways. That's all about kinetic energy. Number 2, excuse me. What category includes emulsions, foams, sols, and gels? What do you call those things? A, do you call them solutions? B, do you call them suspensions? C, do you call them colloids? D, do you call them solutes? Those things specifically are colloids. They're not solutions. They're like basically emulsions and foams are like air in a solid or air in a liquid or liquid in a solid. There are combinations of things, and you call these colloids. That's what the whole chapter is about. Number 3, what is a mixture containing tiny clumps of particles that remain suspended within a mixture and will not settle out? So what do you call that when you have maybe smoke, and they won't settle out, but you have this, Tyndall effect, the light's going through like there, and you can see that there's particles. So what do you call this? A, solution, B, suspension, C, colloid, D, solutes. Again, they're colloids. You have another answer, colloid, C. Number 4, which of the following elements regarding catalyst is not true? Number A, a catalyst increases the activation energy of a chemical reaction. A catalyst, do you know what a catalyst is? They use the catalyst to have a different rate. So instead of having to go all the way up, the process of activation, it lowers the activation energy so that you can like take another route, maybe a couple little hills instead of that one big hill to get there. So the catalyst brings it another route, and the catalyst is never consumed. It's just basically used to get those particles to react. So number A says the catalyst increases the activation energy of the chemical reaction. It doesn't increase any activation, but it actually decreases it. So it says, which of the following elements regarding calcium is not true? So that first one is not true. So B, a catalyst increases the rate of chemical reaction. So, or the catalyst decreases the rate of chemical reaction. The C, the change of H for the catalyst and uncatalyzed reaction is the same. Catalysts may be classified as homogeneous or heterogeneous. No. Basically, the one that is not true is the first one. So the catalysts are classified as homogeneous or heterogeneous. Did I say no? But it is true. So let's go on to the next one. It's kind of confusing there because it says which is not true. And of course, the first one, catalyst increases the activation energy of a chemical reaction, is not true. So, number 5, what type of substance is the scattering of light known as the Tyndall effect? I just told you that, didn't I? So, solutions, A, solutions, B, colloids, C, solutes, D, supercritical fluids. So again, anytime you have the Tyndall effect, which is basically when light comes through and comes the clouds and you see all of it, the light's kind of scattered and it makes that scattering light, that's called the Tyndall effect. And that's because there's colloids, C-O-L-L-O-I-D, in the air. So B. Number 6, which of the following is true if two substances in the same phase are miscible? What does miscible mean? That they basically dissolve in each other very well. So number A says they are completely soluble in each other. B, they are partially soluble in each other. C, they can mix together temporarily but settle out upon standing. D, they do not dissolve in each other to any significant extent. Miscible means that they dissolve in each other. So they are completely soluble and dissolve in each other. A would be your answer. Number 7, when a liquid in a closed container reaches a state of equilibrium with its vapor, which of the following is true? So A, the number of molecules in the vapor state and liquid state are equal. B, the number of molecules evaporating and condensing are equal. C, the process of evaporation and condensing have ceased. D, the liquid is at a boiling point. Okay, which one of these is true? So what is the vapor pressure? What is the vapor? The equilibrium of the vapor pressure is evaporating, right? So evaporating and condensing is basically, the molecules are turning into gas and they're turning back into the liquid. That's vapor pressure. So B is the number of molecules evaporating and condensing. That fits pretty good, B. Number 8, what is the attraction of a substance to the surface of a solid called? A, cohesion, B, absorption, C, suspension. Now, D, I don't have anything down, so, but what it is absorption. It's basically when the surface of a solid absorbs, the surface will absorb some of those attractions, some of those ions and stuff. That is absorption. Number 9, what is the total heat absorbed or released when one substance dissolves in another? We're talking about heat. That's the key word. So A, enthalpy of formation Enthalpy means heat. B, enthalpy of fusion. Or C, enthalpy of solution. Or D, enthalpy of dissolving. So what do you call them when the total heat is absorbed or released when one substance dissolves in the other? It would be the enthalpy of the solution, right? Has nothing to do with fusion or formation or dissolving. Enthalpy of solution, C. When a solution reaches a state of equilibrium, why does the amount of undissolved solid remain constant? So a state of equilibrium basically means it's come to that, it's equaled out. The products and the reactions have been saturated and they're equal. So A, the process of dissolution has ceased. B, the rate of crystallization equals the rate of dissociation. C, no more free solvent is available. D, the solute contains insoluble residue. Well, I know it's not C and D because those are, where'd you get those? So the process of dissolution has ceased. It hasn't ceased. It's still going on in a dynamic relationship. So that's not true. So the answer is going to have to be B. The rate of crystallization equals the rate of dissociation. Yes. It's like you take a crystal of sugar, it's basically a lump of sugar, and you put it in, and basically the crystallization will equal the rate of distillation, so you'll be equalized. As many are crystallizing as they are dissociating with each other. So that's equilibrium. So it'd be 11. What do colligative properties primarily depend upon? So we're talking about colloids there. A, properties of the solute. B, concentration of the solution. C, pressure of the solution. D, temperature of the solution. So colloids. So colloids do not depend on the properties of a solution. And the pressure of a solution doesn't really affect, and the temperature doesn't really affect colloids to that point. It does affect the solutions, but the concentration, the amount of molecules in it affects it a lot. So it'd be B. So B is the concentration. Concentration means how concentrated the molecules are. There's a lot more. They're going to be colliding into each other, and this really will affect, the colligative properties, okay? So the concentration. Number 12. In a solution of glucose in water, what is the glucose? Okay? Well, is it A, the solvent? Is it B, the suspension? Is it C, a colloid? Or is it D, the solute? So glucose would be the solute. It's what you're dissolving in is called the solute, and you're dissolving it in the solvent, which the solvent is dissolving it, which would be the water. So the glucose would have to be the solute, which is D. So let's go on to number 13. How does increasing concentration usually affect the rate of a reaction? So let's see which one fits here. So you're thinking concentrating, like I told her, how does it affect the rate? The rate of reaction is going to get faster because they're going to collide into each other because they're very concentrated. So let's see which one of these fits. A, it increases the rate of a reaction by decreasing the repulsion between molecules. That's wrong because it increases the rate of reaction, but not by decreasing. We bump into each other more, so A cannot be. B, increases the rate of reaction by increasing the frequency of collisions. Isn't that what I described? It has to be B. C says decreases the rate of reaction by increasing the repulsion. Nothing to do with repulsion. They're colliding into each other. D, decreases the rate of reaction by decreasing the frequency of collisions. No, it increases the rate of reaction because it increases the frequency of collisions. That's the collision theory. 13 is B. and homogeneous, number 14, a homogeneous mixture of two or more substances. Oh, these are matching. So let's look. Look on your matching letters and you'll match them up. So, an homogeneous mixture of two or more substances. So when two or more substances mix perfectly together, what do they form? Well, they form a solution, which is I. So because a solution, you can see through. Homogeneous means that, that you have this solution, like you mixed sugar and water together, and you can see through it now because it totally is dissolved. They're very mistable. And so that would be a solution. Number 15, a protein catalyst found in living things. So in you have a lot of these catalysts that help your reactions, especially in the digestive tract and such. To digest things, we have a lot of these, and they are catalysts to make the reactions go faster so we can digest food fast. Plus, you have them all over in the cells and everything. What are these things called? Enzymes, right? C is enzyme. Number 16, a substance that slows the rate of reaction. When it slows the rate of reaction, what does it do? It inhibits it, right? So F is inhibitor. Number 17, a series of steps describing the way in which a chemical reaction proceeds. We call these series of steps a mechanism, right? So which one says mechanism? Well, H says reaction mechanism. Sometimes it goes to a chain reaction too. Well, let's find what the next question is. It says a chemical reaction in which the products of one reaction cause the other more reactions to occur. So A would be chain reaction. So that would be 18. Number 19, a reaction in a proposed series that has a greater activation energy than others and thus occurs more slowly. So when you look at the slower one, you think that's the determining step is always the slowest step. It takes the longest, and that's the step that is the most important. So you call this the rate determining step, G. Okay? These are all in your book. Number 20. Let me see if I can read this one. Oh, the erratic movement of colloid particles due to random molecular collision that keep them suspended is known as the Brownian movement. Yeah, it is. That Brownian movement is that all atoms are moving. Even atoms in solid things are moving at all times. And they called it the Brownian movement. True. Number 21. Substances that dissolve in water to produce ions that can conduct electrical current are called colloids. No. Colloids are those little particles suspended in solutions or suspended in the air. So what are these dissolved substances that are ions that are in things like Gatorade? What are those ions called in Gatorade? They are called electrolytes, right? So you're going to have a lot of electrolytes in your Gatorade, and a lot of electrolytes and IV fluids and stuff. Electrolytes can put an electric current through, but they're ions. So it'd be false, and put in the word electrolytes. The energy diagram there that you have represents a what? Well, if it starts high and it goes down and gives off all its energy at the end, it's going to be exothermic. If it starts low and it goes up and goes higher, it's going to be endothermic. So which one is this? It looks like it starts high and it goes lower. So it's going to be exothermic. It says the energy diagram represents the endothermic. No, it's false. It's exothermic because as it goes up, it's letting out all those products and it's going to be lower. So that looks like an exothermic. Number 23, the minimum kinetic energy that a molecule must possess to undergo a chemical reaction is called the potential energy. No. It's called the activation. The minimum energy to get to that top part where it's going to have the transition stage at the top, the activation peak is going to where it's activated and it turns into another, it transitions into another type of particle, molecule. So that's the activation energy. There's not really potential energy is before that gets to that peak. So anyway, number 24. Tiny emulsified droplets of grease or oil suspended in water by soap molecules are called micelles. Yeah, they are called micelles. They look like little missiles too. And the soap little parts, little missiles. Remember that picture I showed you that comes around, these little missiles attached kind of like, and they lift up the grease out so you can wash the grease away? Missiles, that's true. Number 25. A solution that contains as much dissolved solute as possible under equilibrium conditions is saturated. I went over that before. Sure is. It sure is saturated if it contains as much dissolved particle as possible. Number 26. When two opposite processes continuously occur at equal rates so they offset each other, the system is said to be in a state of balanced equilibrium. No, it's called equilibrium, but it's not called balanced equilibrium. It's called dynamic. Dynamic, D-Y-N-A-M-E. So it's called dynamic. Your dynamic means it's constantly going. So, number 27. An ion or molecule surrounded by water molecules in an aqueous solution is hydrated. Yeah, that's right. Yeah, they're hydrated. Water's hydrated. That's true. Number 28. The quality of a solute for a given quality of solution or solvent is known as a concentration. So, the quality of the solute for a given quality of solution or solvent is known as concentration. I'd say that was true. I'm not too sure about that one, but go on to number 29. In a chemical reaction, the change in concentration of a substance divided by the time for the change is the reaction rate. Yes, that's the rate, like miles per hour or whatever you go. Basically, the change in concentration divided by the time is going to be the rate, because rate is measured in time, right? So true. Number 30. So, which of the following best explains why a catalyst increases the rate of reaction? A, it increased the activation energy. B, it makes the molecules collide less often. C, it makes the molecules collide more often. Or D, it reduces the activation energy. The one thing we know about a catalyst is it's going to reduce the reaction energy to take another path easier to get there, so the molecules don't have to use so much energy and they get more products. That's why you want to use a catalyst. So it'd be D. Which of the following best explains the meaning of the phrase like dissolves like? So they're going to be polar and nonpolar, like polar dissolves polar and nonpolar dissolves nonpolar. So A, substances in the same state will dissolve each other. Well, same state means, solid or liquid, and so that's not going to do. B, substances with similar molarities will dissolve in each other more readily. Well, we're not talking about molarities. We're talking about polar and nonpolar, right? Number C, substances with similar intermolecular forces. That looks good. Polar and nonpolar are intermolecular forces, aren't they? Because the likes dissolve in like because they have one side is polar, or then they're going to repel each other or draw each other to each other. So C would be your answer. D says substances with similar electron configuration will dissolve in each other more readily. So it goes with the intermolecular forces. So, which are like versus like, basically ions, on one side, and on the other side of the pole is going to be non-ionic, and how they, like water is positive pole and a negative pole. So let's see. Let's go to, I'm going to stop there, and we'll start on number 32 in the next, because we're getting kind of long here on this video, but we will go on to the next and finish it up.